Hi, I am Harish, a member of Group 2. We are gonna discuss the separation of components of a mixture. At the end of this discussion, we are expected to determine the procedures of separation of one component from another, calculation of a weight of a mixture recovered using percentage yield, and a percentage of each component formulas. Mixtures are any material made up of two or more substances, and we use and consume them daily. Everything we see are composed of two or more substances or mixtures. The isolation of pure components of a mixture requires the separation of one component from another. The chemists develop techniques that separate components from another. These techniques are sublimation, extraction, decantation, filtration, and evaporation. Sublimation involves heating a solid until it passes directly from a solid phase into a gaseous phase. In short, this is a process of converting solid into gas. The reverse process of sublimation are called condensation or gas to solid. Extraction uses a solvent to selectively dissolve one or more components from a solid mixture. It uses another substance, mainly a solvent, to dissolve or separate insoluble solid to soluble solid. Decantation separates a liquid from an insoluble solid sediment by carefully pouring the liquid from a solid without disturbing the solid, as you can see at the figure 3.1. Filtration separates a solid from a liquid using a porous material as a filter. It uses another material to filter or separate solid from a liquid. Examples are paper, charcoal, and sand. Evaporation is the process of heating mixture to drive off in the form of vapor a volatile liquid to make remaining component dry. Mainly, evaporation occurs when boiling a substance. The mixture that will be separated in this experiment contains three components: naphthalene, common table salt or sodium chloride, and sea sand or silicon oxide. The separation will be done according to the scheme figure 3.2 by heating the mixture to sublime the naphthalene, dissolving the table salt with water to extract, and evaporating water to recover the sodium chloride and sand, as you can see in figure 3.2. Also, the techniques that I've discussed before are being used in this experiment.
Hello everyone, I'm Alinor Odasan and I'm from Group 2. I am tasked to report to you about the data presentation of our activity. Last Tuesday, we conducted our experiment with activities 2 and 4. So now, I will be using this formula to present the data to you, and we will of course know the percentage. First, I'll demonstrate to what their corresponding weight is for this activity. Then first, we have the specified or given corresponding weight of beaker 1, which is 99.185 grams. Weight of beaker 1 and mixture, so we combine it, so 103.697 grams. Then number 3, weight of mixture, we subtract the 103.697 minus 99.185 grams in order to get the total of this. So equals 4.512 grams. Then let's proceed to weight of naphthalene collected. So assuming we have a given naphthalene collected, 3.215 grams. And then what is the weight of beaker 1 in solid after sublimation? So as we all know, sublimation is it is a process of solid to gas. Then we have already the weight of beaker 1 in solid after sublimation, 99.715 grams. Then let's proceed to weight of naphthalene by difference to number 2, which is the weight of beaker 1 and mixture minus weight of beaker 1 in solid after sublimation, 103.697 grams minus 99.715. So like this, we subtract this 103 99.697 grams minus 99.715 grams. So, we have the results, 3.982 grams. Then, let's proceed to the weight of beaker 2. Weight of beaker 2, we have already given corresponding weight of beaker. So, 99.185 grams. Then, weight of beaker 2 and sodium chloride. So, sodium chloride, this is given also. Given. So, then, weight of sodium chloride, we subtract this in order to get this result. We subtract the 102.355 grams minus beaker 2, which is 99.185 grams. So, the result is 3.170 grams. Then, let's proceed to weight of beaker 3. Beaker 3, as usual, given 99.185 grams. And then, let's proceed to weight of beaker 3 and sand. So, we combine it. Then, it is also given. Then, weight of sand. So, we have to subtract the this number 10 and number 9. So, in order to get the result, 102.901 minus 99.185 grams. So, we have a weight of sand, 3.17, and a weight of sodium chloride, 3.170, then a weight of naphthalene collected, 3.215. Then, let's proceed to the calculations. Weight of recovered solids. So, paano natin siya malaman? So, we have to substitute this. 5B. So, 5B, this one, 5B. 3.982 grams. 3.982, then plus number 8. So, number 8 is weight of sodium chloride, which is 3.170 grams. So, plus 3.170, and then we have to add the number 11, which is the weight of sand. So, 3.716 plus 3.716 grams. And a total of this is 10.868 grams. 10.868 grams. So, we have a 10.868 grams weight of recovered solids. So, percentage yield, percentage of solids recovered. So, I have a formula here, percentage yield. In order to get this result, we have to use this formula. Percentage equals grams of solid recovered over grams of initial sample times 100. Example, 12. Number 12. So, the number 12 here is the 10.868. This is already our number 12. 10.868. Then, number 3. So, we have to divide in number 3, which is the corresponding equivalent is 4.512. Divide 4.512 grams. And then, we have to times it in 100 equals 240.87%. So we have a percentage yield or percentage of solid recovered by 240.87%. The same as process also 3.982 grams divide number 3 4.512 times in 100 equals 88.25%. Then same process also, we have to use the percentage of sodium chloride, percentage of each component in the mixture. So we have to use this. This is the sodium chloride, 3.170, and then divided by number 3, our mixture, 4.512 times 100. Then we have a 70.26% percentage of sand, so, or the percentage rather. Then number, let's substitute it. So number 11, 3.716 over divided by 3. So weight of mixture, our number 3, 4.512 times 100, and then we got the result 82.36%. So that's all for my data presentation, and thank you.
These are the follow-up question. Number 1. A student completed the experiment but found that the total amount of material recovered weighed more than the original sample. So what is the most likely source of error? And how may it be corrected? So the fact that the material recovered weighed more than the original sample is a result of the water moisture present in the recovered sample. The water present in the sodium chloride and sand is most likely a source of error. In order to heat the sodium chloride and sand to evaporate the water to ensure dryness. Number 2. A student found the weight of naphthalene collected was less than the weight determined by difference. What would account for the smaller amount of naphthalene collected? So, the weight of naphthalene collected was less than the weight determined by difference. Since some naphthalene escaped as vapor during the heating process, some deposited naphthalene could not be removed from the bottom of the evaporating dish. And some collected naphthalene was lost on the lab bench or in transit from the lab bench balance. As a result, not all of the naphthalene that sublimed was included in a naphthalene sample that was weighed. Number 3. Mount ball and closet gradually disappear over time. What happens to this material? So, at a normal temperature, the solid mount ball underwent sublimation, turning from solid to gas and filling the closet with an odorless gas that keeps moths away.
Hello, for question number 4. A package of freshly picked sweet peas weigh 454 grams. The peas were fresh dried and the recovered peas weigh 122 grams. What was lost? What is the percent composition of these volatile components? During the freezing process, hence the water in the peas was lost. The present composition of the volatile components. So, ang grams naghatag sa fresh peas is 154 grams.
Then sa freeze-dried and recovered piece is 122 grams. So ato na siyang i-calculate. So pag calculate nato is 154 grams minus 122 grams divided by 454 grams is multiply by 100 equals 73.1%. Mao na yung atong volatile components. Number 5, in 100 grams of sweet peas, there are 14.5 grams carbohydrates, 5.7 grams sugars, 5.1 grams dietary fibers, 5.4 grams protein, and 0.4 grams fat. Calculate the percent composition for each of these components. So ato siyang i-calculate gamit ang components formula. Carbohydrates na siya grams na 14.5 grams. Then divided by 100 grams of peas. Multiply by 100 equals 14.5% carbohydrates. Sa sugar naman, na siya grams na 5.7 grams divided by 100 grams peas. Multiply by 100 equals 5.7 grams sugars. Then sa dietary fibers, na siya 5.1 grams divided by 100 grams peas. So, mo na siya ang given 100 grams peas gyapon ang i-divide. Multiply by 100 equals 5.1% dietary fibers. Then, sa protein naman, na siya 5.4 grams divided by 100 grams peas. Multiply by 100 equals 5.4% protein. Then, sa fat is na siya grams na 0.4 grams divided by 100 grams of peas. Multiply by 100 equals 0.4% fats. Then number 6, a student isolated the following from a sample of 1.132 grams. For naphthalene, 0.170 grams. For sodium chloride, 0.443 grams. For sand, we have 0.499. Then solid recovered is 1.112 grams. Calculate the percentage yield and percentage of each component. Show your solution. So, ang gamit nato na formula is percentage yield formula. So, ang formula sa percentage is percent yield equals grams of solid recovered divided by grams of initial sample multiplied by 100. So, percentage yields equals atong solid recovered is 1.112 grams divided by 1.132 grams multiply 100. So, ang answer is 98.23%. Percentage of each components in the mixture formula. So pagkuha na to sa mga mixture, ang atong gamiton is components formula. So ang formula sa components is components percent equals grams of component solid divided by grams of initial sample multiplied by 100. So sa percent of naphthalene equals 0.170 grams. Mao na grams sa naphthalene naghatag. So divided by siya sa 132 grams multiply by 100 equals 15% naphthalene. So ang among naphthalene is 15% naphthalene. So sa percent of sodium chloride naman is na siya grams na 0.443 grams. So, divided by gyapon siya sa 1.132 grams sa initial sample ni Ja. Grams sa initial sample multiply by 100 equal, ang among answer is 39.1% sodium chloride. So sa sand naman, percent of sand, ang grams sa sand is 0.499 grams divided by 1.132 grams multiply by 100 equals 44.1% sand.
And now let's proceed to the conclusion. So in this activity, we conclude that chemists have developed techniques techniques and separation of one component from another to isolate the mixture. These methods are sublimation, extraction, decantation, filtration, and evaporation. The separation will be done by heating the mixture to sublime the naphthalene, dissolving the table salt with water to extract, and evaporating water to recover dry sodium chloride and sand. And after the experiment, we get the weight of the beaker and mixture so we can proceed to the calculations. The weight of solid we recovered is 10.868 grams. Percentage of solid recovered is 240.88%, while naphthalene is 88.25%, 70.26% for sodium chloride, and 82.36% for the percentage of the sand. And all these techniques involves changes in physical state of a chemical compound, and no chemical bonds have been broken in undergoing a transformation from one state to another. And that's all. Thank you for listening.